We left off with bone markings. We were talking about depressions and projections. Depressions are indentations, and then projections, things that elevations off bones. And just what you have is you have examples here, and then understand that these aren't the only examples. So you have a projection, which is a bump process, which is a bump. And you see that on the zygomatic arch. That's the turquoisey color. Ramus is going to be the angle of a bone, and certainly your mandible, your jawbone, has an angle. Sinus is going to be an opening in a bone for to make it lighter, and also for air in terms of our speech production. A foramen is a rounded little hole, and generally for blood vessels or nerves. You have a fissure, which is definitely a slit, but it's kind of a narrow one, and it has I guess an elevation. The surface is kind of roughed up in terms of a fissure. A meatus is a passage or channel, particularly an opening of a channel, and this is usually, a meatus is usually internal, except for in the nose area, I guess. You have a canal, which is just like it sounds like. It's going to be an area where something can pass through and be somewhat protected. Then in the rest of the skeletal system, that was mostly the head, and understand that you have those processes throughout the bones. So another area that you have sulcus and fossa, and these can be depressions, and they're generally where a tendon can be regulated, so it can be not so much attached. It can be attached, but it also can lie in there in a sulcus or a fossa. A fossa, generally we think of that as a place where you're going to have a presence of a joint. Trochanter are going to be large projections, and with trochanter you think of a great degree of range of motion. Crest, just like we think of the word crest, it's the prominent ridge, and you have the crest of the pelvis. And spine is a spine is not only a pointed process, but it's a process where you get to the pinnacle, where you're at the highest point of where two things come together. It may not be the highest point on the bone, but it's the highest point where two things come together. A line is going to be a low ridge. Tubercle is smaller than a trochanter, so it's still a rounded projection, but smaller. And then tuberosity is a little bit rougher. Tuberosity tends to be a little bit more obscure than the tubercle or the trochanter. The head of a long bone, and so these would be processes where bones tend to become joints. So the head is going to be the portion of the bone that's going to form a joint with another bone. And this is generally in relationship to, you generally see a head on a long bone, as well as a neck where you're going to have a narrowing of the bone. You have a facet, which is kind of a flat surface. Facets are usually covered by cartilage. A condyle, rounded process, and again we associate all of these with articulations, with joints where bones come together. And then a trochlea, again, this particularly with regard to the elbow joint, trochlea, where you think of a, I hate to say the word pulley, but it's the design is the design looks like a pulley, but the elbow joint doesn't function like a pulley. And then on to the structure of long bone. With regard to the structure, you just have areas that are necessary to identify. The long aspect of the bone. So the length of the bone is called the diaphysis, the shaft of the long bone. The diaphysis is generally compact bone. It's very dense, strong, compact bone. That's by definition, long bones need to be strong. They usually tend to be the ones that we stand up on or we use for lifting, etc., in relationship to their attachment with muscles, etc. So don't get me wrong, I'm not saying bones lift, but we use that part of our body for that. Think of our legs. We're standing upright, although the legs are not considered the weight-bearing portion. The weight-bearing portion is the axial skeletal system, and the legs are part of the appendicular. In the diaphysis of the long bone, there's a space in the center called the medullary cavity. It's also called the marrow cavity. This is where you find yellow marrow. The epiphysis is the ends, and with the epiphysis you have the end that's closer to the midline, and that's the proximal epiphysis. And then you have the epiphysis that's farther from the midline, and that's the distal. And so you have the ends of a long bone, and whenever you have two, you have to distinguish one from the other. And with that, we always go back to that famous anatomical position and relate the epiphysis, or the ends of the long bones, to the midline, and closer is proximal, further away distal. The epiphysis is where you're going to form a joint with other bones, and most of the time the epiphysis is going to be spongy bone. And spongy bone has AKAs cancellous bone and trabecula. I tend to use the word spongy, but some other textbooks can use other of the AKAs for that. And spongy bone is not covered with the same arrangement of compact bone, but a very thin layer of compact bone, which we call the cortical layer. So it is the same arrangement as compact bone, but it isn't as thick, and it certainly isn't as strong. The area where the epiphysis and the diaphysis meet is called the metaphysis. Metaphysis. I always find that so hard to say. Sorry, but the area between, the middle, you can think of, and that basically is the area where the two types of bone meet. And when you think about it, if you have one type spongy bone on the epiphysis and then the diaphysis is compact bone, there needs to be a transitional area. So you can think of this area as the transitional area between the two types of bone. Both spongy and compact are made of the same material, so calcium salts in a non-living matrix, but the design is quite a bit different between the two. The flat bone, remember you have flat bone making the walls of the skull, you have flat bone in your sternum. Flat bone are designed a little bit different in the fact that it's kind of a sandwich of spongy bone between two layers of compact bone. Those two layers of compact bone make the bone very strong. However, the spongy bone, anytime you have spongy bone, you think of that's where you're going to have your red bone marrow. So in the flat bones, you have this red marrow there, and spongy bone between the compact bone is called diplo. So you have kind of a different arrangement in certain flat bones, and when you think about it, it's kind of a good thing to have this type of arrangement of bone. It's strong. It's not as strong as your femur or the bones that you stand on or that your legs are made of, but it's a strong enough bone to protect the brain, but not so heavy that you can't lift your head up. So when you think about it, it really is a very good design for the bones of the skull. Moving on from basically talking about bones generally, let's talk a little bit more micro. So the cells of the bone, and we'll get started on this, and hopefully we can get pretty far into the cells of the bone. Bone cells, bone is living tissue. It's redesigning itself. It's performing its metabolic processes. It's continually dying off, replenishing itself. But the cells only make about 2% of bone mass. That's not a lot. The living aspect of it, the living cells, only about 2% of bone mass. There are 4 types of bone cells: osteocytes, osteoblast, osteoclast, and osteoprogenitor cells. So bone stem cells, you could say it like that. That way it won't be such a mouthful. With the first one you have on the left, top left, is the osteocyte, and this is what we consider a bone cell. This is the mature bone cell living in its matrix, performing the job of being a bone, being bone tissue. And it has a lifespan. It needs nutrients to come to it. It has waste products away, and that's what these little rivers look like. They're called canaliculi. In and amongst those canaliculi, you have this calcium matrix, and the canaliculi is where blood flow comes. This is where nutrients come, where waste products are taken away. So the osteocyte sits in a lacuna. That's the space it sits in, and canaliculi are the highways, I guess you might say, that bring needed nutrients to the living cell of the bone called the osteocyte. And in order to have this process of continually redesigning bone and growing bone and renewing and remodeling bone, you have 2 cells that work together, an osteoblast and an osteoclast. And so the osteoblast is considered immature osteocytes, bone cells, and only immature not because they don't know how to function. They know how to do their job as an osteoblast, but their job before they become osteocytes is to secrete organic compounds of the bone matrix. So basically to make more of the matrix, and they tend to make the matrix around themselves, so they kind of enclose themselves in their own lacuna with the canaliculi coming out. And when they have surrounded themselves, then they become osteocytes. They no longer secrete, but they perform the function of a mature bone cell. So that word mature, immature, kind of misleading, but more but everybody uses it. Don't get me wrong. I'm not going to suddenly redesign the language of how we talk about bone cells, but it's not. Don't think of that as in layman's terms. And then osteogenic cell, the stem cell. This is what gives rise to more osteoblasts. So it gives rise to the osteoblasts give rise to the osteocyte. And then you have the osteoclasts, and they have multiple nuclei, so we call them multinucleate. They secrete acids and enzymes to dissolve the matrix. So they cleave the matrix off and dissolve bone, redesign bone, take the minerals off if the minerals are needed elsewhere. And what I'm going to do is leave this now, and we'll pick it up on the next one.